Welcome to our exploration of the science behind grease. Today, Sandy Cowan, our grease technology manager, will guide us with some technical aspects that play a crucial role in grease performance.
By incorporating some polymer into the grease. So how does that work? How does the addition of a polymer actually make the consistency, the viscosity more consistent? Well, polymers are segments that can coil and become very large, or they can compress. At cold temperatures, polymer structures, these long hydrocarbons with repeating chains, get very compressed. So if this room is a bearing and we're the grease, if it's very cold, the polymers are compressed. It's not just one, there are many hundreds of thousands, but they're all compressed. So the impact on the viscosity, yes, it will raise the viscosity, but the impact is less than when it's hot. What happens to a polymer when it gets hot? Well, the answer is they expand. They get extremely large and they may be very coiled. So they're taking up not a small space now in the oil, they can take up a very large space. And as they expand, and thousands of these are expanding, the impact on the viscosity as it gets hot is they thicken the oil. So as the oil would naturally become less viscous as it heats up, the polymers then expand, and in expanding, they increase the viscosity, thus countering the reduction in viscosity that you can see in the oil itself. There are fluids that are called Newtonian, and then there are fluids that are called non-Newtonian. A Newtonian fluid is one that does not change viscosity as the force or the shear stress changes. Examples would be something like water. For example, if I had a bowl full of water and I were to apply a rapid force to that surface, you're not going to see the water immediately harden or thin. I can slap the water's going to splash everywhere. It does not change in viscosity. There are other examples of fluids that are Newtonian. Those would include things like straight mineral oils, or milk, or for that matter, air. As you drive your car through the air, you don't see the viscosity of the air change. Grease, however, isn't Newtonian. It's in the category that's referred to as non-Newtonian. And as you might imagine, these do change viscosity as the stress is applied. If you're like me, you remember when we bought ketchup in glass bottles. And so it wasn't uncommon to try to put some ketchup on your French fries and you tap on the bottom, nothing happened, you tap harder. And then finally you'd hit the back of the bottle very hard, and what happened? Half of the bottle ended up on the French fries. Well, ketchup's called non-Newtonian, and it has the characteristics of when it reaches a certain stress, it actually reduces in viscosity, which is why so much ketchup came out of the bottle at one time. There's a real good reason they're sold in plastic bottles today. Other examples include quicksand or oobleck. Oobleck is a term from a Dr. Seuss book. It's actually a name used today for a mixture of cornstarch and water, which is what I have here. So it's just this mixture, cornstarch and water, and it has odd characteristics in that if it's under pressure, it's a solid, but if I take the pressure off, it becomes fluid. So unlike water, if I slap the surface, I'm going to apply a rapid shear stress, and the viscosity, even though you can see this, definitely would pour, the viscosity is going to increase. So I can't make it splash out of the container because the rapid stress that I'm applying is causing the viscosity to increase. Now, having said that, let's say I have some in a fist, it's a solid, I reduce the pressure, it becomes a liquid, it becomes fluid again. So this is an example of a non-Newtonian fluid and what they do. Greases change viscosity as the pressure or the shear force changes. So in summary, what are the factors that can affect the flow characteristics of the grease? Number one, the viscosity of the base oil that you use. The hardness of the grease, whether it's a semi-fluid, something in between, or a brick grease. And lastly, the fact that grease changes viscosity as the shear force changes upon it.
If you'd like more information on grease or help in selecting the right grease for your application, please visit mysticloops.com and visit our resource center.